Hello, everyone, and welcome to today's SANS webcast, using Osquery and MITRE ATT&CK to provide analytics for incident response and threat hunting, sponsored by Uptycs. My name is Carol Auth of SANS. Today's featured speakers are Dave Shackelford, SANS analyst, instructor, and course author, and Guillaume Ross, principal product manager at Uptycs. He will be moderating today's webcast. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Dave.
Awesome. Thanks, Carol. And hey, thanks everybody for being here with us today. It's exciting as always to explore some more kind of cutting edge methods and techniques and concepts in the realm of really figuring out what in the world's going on within our environments, which these days tends to be a lot, especially as our environments get a lot more distributed. We've got hybrid infrastructure that's running in both public cloud environments and on-premise. We've got a lot of different system types, right? So it's no longer just servers, it's virtual servers, it's containers. It's all sorts of different platforms that are potential targets for attackers. And as we get more spread out across this infrastructure, especially in big environments, all of the problems of the past, in my opinion, just get compounded, right? So we've got more to look at, less time than ever before to do it, and we really need speed and efficiency across the board for processing and sort of looking at endpoint types of systems, especially when we know we need to look at numerous systems simultaneously. And again, speed really matters here. So it's exciting to be here with the folks from Uptycs and actually have a chance to talk a little bit about things like Osquery and sort of where it fits into the scheme of attack frameworks. And of course, MITRE ATT&CK is a pretty well-known one that we want to touch on here, but particularly for not only responding to stuff. I mean, look, I think we all know that that is a paramount situation and element of a security strategy and program today, but we've gotten a lot more proactive too, and as long as we've got the right tools and ways to approach that, that's something that we're really seeing some significant evolution in the security industry with as well. So, yeah, if you wouldn't mind just going to the next slide, where I introduce us and say, hey, it's us. So I'm Dave, and I'll be sort of kicking us off here, doing a little bit of a brief introduction to the landscape of what's happening out there and sort of what the real sense of urgency is around these days, which I will then be handing off to Guillaume, who's going to be talking about really the sort of spectrum of newer tools in the form of Osquery, how that can be used. You guys are in for a treat today. He's got lots of really cool information to share about how Osquery can ultimately benefit you in a lot of different ways. So let's get right to it. Let's go on to the next slide, please, Guillaume. And so this is, look, I always like to go try to grab stats and things from the industry, and there's tons of this now. I mean, in fact, it's almost impossible to escape from and get away from all these different types of industry research and reports that basically all tell you that the sky is falling. But I'm sad to say, the consistency in all of these things in the past several years has been that, in fact, the sky is falling. It's ugly, right? We got a lot more breaches. We have tons of incidents. The attackers are not limited in their agility and capability to be able to go do, sort of what they want to. But what I always look at is, like, what are the trends? What's changing out there in the landscape, right? In other words, are these guys doing something really different? Is there some significant pivot that's happened in the attacks that we're seeing in the landscape? And sadly, in the past couple of years, it's again been fairly consistent as to what's going on. And I really do like the folks at Verizon and their DBIR. I know most of us know about that, but if you really think about, sort of what that entails, what these guys are coming up with, they're doing a mass processing of information that, and they're very, sort of specific on data science. And what we saw a minute ago was really just sort of that list from the last 2019 DBIR that's the top issues in breaches, right? The top attack techniques. And, the top two are the ones that really matter to me, because what it demonstrates, I mean, obviously exploitation of vulnerabilities is a big deal. Buffer overflows, brute force, we get this, right? Anybody in security is familiar with most of these, but the use of stolen credentials is astonishingly far and away the number one. I mean, it's up well above 60%, closer to 70% of the cases that we saw. And then the other one behind it is still huge too. It's, over 40% using backdoors or command and control channels. So stolen creds, some exploitation, backdoors and command and control channels, all of these are things that ideally we've got to go figure out at the endpoint and process again at scale. So let's go to the next slide. And the next slide really explores some of the information that came out of our most recent endpoint protection and response survey. So we typically do our surveys every year or two. And so this is the one from 2018 where we had some really good information coming back and people saying, look, 42% of the folks that came back to us said, yeah, we had at least one endpoint compromised. But the more interesting stuff for me is the other stats, right? 20% had no clue whether their stuff was compromised at all. What are the endpoints? Where are they? And has any of it even been compromised? If you can't answer those questions, it's really time to start looking at tools and methods to more proactively go discover what's running and, ideally figure out what's running on those systems, looking for specific indicators or behavioral patterns that are indicative of attack scenarios. Now, the good news is that we did see an uptick from, the previous years, which were really low numbers because this was fairly new, but 20%, so 1 in 5 organizations came back and said, hey, we are starting to find issues by going out there and performing some proactive hunting. And, it's not to say that you just have infinite time to sit around doing this either, which means you've got to have some efficiency around this. And this is pervasive across all of these different workload models. Let's go to the next slide. So, good stats, always helpful to sort of frame the things that are happening out in the industry. And I get asked this question, and I'm sure Guillaume and all the folks at Upticks do too, is like, what is everybody else experiencing? What's happening out there? And, it's not to say that misery loves company, but we know that we're all potential targets these days. And I think having tools like the Enterprise Attack Framework from MITRE, and they've added in the pre-attack sort of recon and planning emphasis for attackers too. What we really want to focus on from a threat hunting perspective, though, is this sort of right-hand side, right? The delivery, the exploitation, command and control or the control of systems, execution, and then, of course, the persistence and maintenance within these environments. And we know a lot about this. That's what's amazing is that, I'd say security, we really understand attack cycles more than we ever have in the past. It's less a problem of understanding what an attack cycle may be. It's more of an attack, cycle, sort of implementation model for our security controls and processes. In other words, where do we best fit our different controls and, frame up how we can approach things like threat hunting in this model. So ideally get in front of this as far as we can, right? I don't think any of us are under the delusion that we're going to avoid or prevent all breaches. But the more we can prevent, the better, obviously. And certainly the further ahead of this we can get, the better as well. So look, ideally, I want to do such a good job of proactive threat hunting that if somebody does cross from the weaponization into the delivery mechanism and or delivery to exploit mechanism, I want to be able to find that and find it as fast as humanly possible. And for large organizations at scale that are challenged with resources, I think we really need to look at better tools and mechanisms by which we can do so. So let's go on to the next slide. And really what this just comes down to is the notion of common challenges, right? We've got hybrid environments, lots of diverse systems. We still have some old stuff, I hate to say it, but we do, internal legacy systems, as well as virtual servers and containers. And we also see a lot of problems around performance. So this is one of the biggest headaches I consistently hear about with clients that, even today I'd say, overall the landscape of endpoints gotten better. And there's been a lot of emphasis on that, but it's still not perfect. There's still a lot of churn and a lot of overhead that goes with this. As soon as you tell somebody as a security professional that you want to install an agent on something, there's a collective groan from operations teams because, they're still sort of firmly entrenched in the world of, like old school antivirus and even some of the different types of EDR platforms, they can be pretty heavy. And now you move that out to cloud, heavy equals more money. And I mean, you can directly tie that correlation into costing, and that's no good for us either, right? So let's go to the next slide. And so that, this really just begs the question, where can I focus? How can I adapt some of the things that I need or want to do in my environment? It's like, what can I do to be, a little bit more effective? Well, that's an interesting question, because I'd say today we'd all agree more threat hunting is probably smart. Looking across the entire infrastructure to the best degree possible is useful, as long as we have tools that can accommodate for that. And being able to know what we want to look for and assess system state quickly and process that quickly, that's really the key to the whole thing. So there are still challenges, right? I mean, really, we need to figure out how I can arm sort of the, tier one folks to do this rapidly, right? Go find stuff and then feed it up the chain in terms of escalation. And how can I scale, right? So these are big things that I think we all sort of recognize today that we need to address, but that doesn't necessarily mean that it's easy. So let's go on to the next slide. And with that, I'm going to hand it off to you, Guillaume.
All right, thanks a lot, Dave. Thanks everyone for showing up to this webinar. So I'll talk a little bit about what OS Query is, as well as what Uptycs does with OS Query. Essentially, OS Query is an open source agent that Uptycs leverages. It's a very light agent because, as Dave was saying, performance is extremely important in terms of cost, especially in cloud environments. If you have 100,000 Linux servers and something takes 10% CPU on all of them, you're going to need another 10,000 servers, which is definitely something that people would prefer to avoid. And using all of the data from OS Query, we're able to provide our customers with solutions for doing threat hunting, as well as a bunch of other use cases like audit and compliance, vulnerability monitoring without scanning, file integrity monitoring, and much more. To keep things simple, whenever I have a dark background, you'll see that what I'm talking about applies to the open source version of OS Query. So everything I'm going to convey in this webinar, you can go ahead and use that with the open source version of OS Query. And when I have a lighter background, these are Uptycs screenshots, which require the Uptycs solution. So the reason I love MITRE ATT&CK is because there's too many best practices that are unrelated to real attacks, right? Like, we've been doing password expiration policies forever because we've been doing them forever. There's many different examples like that. However, MITRE ATT&CK is based in reality. So I thought we could take a look at a real attack that happened and see where that maps on the MITRE ATT&CK framework, and see how we could use OS Query to improve our detection or perform threat hunting, as well as how we can monitor our defensive controls, because detecting attacks is one thing, but if we can make our defenses better at the same time, then that's even better. So a little introduction to OS Query for those who aren't familiar. It's an open source agent that works for Mac, Linux, and Windows, also supports Docker via the Docker APIs. And I haven't indicated it here, but it also works with FreeBSD, though that's a use case that's a little bit more rare. It actually works great. And what it does is it converts, or it pretends your operating system is a virtual SQL database. So you have 240 different tables with a lot of data about the operating system. We'll look at some of these tables, but they include data like who's logged in, what user accounts exist on this system, what network connections are being established, what Chrome extensions are present on this machine. So with all of these tables, the possibilities are almost infinite. And because it's open source and the schema is also very open, using SQL as the query language, it's extremely easy to share these queries and to learn how to use it. You don't need to learn a proprietary query language, for example. It uses SQLite for query execution. So it's true SQL, and it can either execute scheduled queries or real-time queries. So you can tell all of your systems, okay, every day I need to know if my Windows updates are installed on my machines, but you can also ask queries in real time of your systems if you have a system like Uptycs in front of it, or anything that supports the OS Query APIs. Because it's cross-platform, it lets you reuse techniques to other systems. The ways you would investigate something on Windows, Mac, and Linux are often pretty different, but OS Query lets you bring these much closer together by providing a lot of tables that work the same way across all platforms. And it's very fast and reliable. OS Query has its own watchdog that ensures that if you were to run a query that's too processor intensive, for example, it will terminate the agent, restart it, and make sure that query is not run again until you remove it from that list of banned queries. So for example, if someone tried to read the hash of every single file on your operating system, of course that would take forever, but that query is going to be blocked, and so someone can't make that mistake twice. So it's extremely flexible. It's great for all of these use cases that I described that Uptycs can perform. And because of these 240 tables, its possibilities are really infinite. Originally, it was created by Facebook in 2014 because they needed an agent to run on their Linux servers and Macs that didn't have a huge performance impact and that could be used for many different security use cases. But nowadays, since last year, the trademark OS Query and the name is owned by the Linux Foundation, and it's run by the community. So there's the OS Query Foundation now with a proper board that manages the OS Query project, which is great. So when I say it abstracts the operating system and makes it look like it's a database, think of you're trying to understand if there's a process called Apache running. If you were on a Unix system, you might use PSAX and grab for Apache or HTTPD. But if you were on Windows, you'd probably use some PowerShell or the task manager. Now, if these machines were running OS Query, you could simply use SQL to select from the processes table where there's a process with the name that looks like Apache. So if you look at this simple example, it actually looks more complicated to do SQL than the command line. However, when you consider that there's dozens and dozens of different commands to get to different types of data on the system, it quickly becomes a huge advantage to use OS Query. And there's no huge database that's built on the machines. When you request the data, it's sent back to you as if it was a database. But the main data that's kept on the system is really only for caching purposes. So it's not building a big database that it's updating all the time. It waits for the query to either be scheduled or distributed in real time. And then the data is returned over TLS to your Uptycs server or any server that's compatible with OS Query, which is awesome, especially for laptops that might not be on a VPN, might not be on your LAN. So you can get the data back at any point in time and do some threat investigations, even if people are at Starbucks or working from home, which I'm sure is pretty common nowadays. And in terms of the attack framework, OS Query has a really heavy coverage on most tactics, especially when the endpoint is concerned because it's an endpoint tool, but also when network traffic is concerned because it's really good at seeing network traffic coming from the endpoint. So in any situation where you don't have great network monitoring, again, people working from home is a great example, OS Query is also good for the attack matrix when network data is required. And you'll see the coverage is very good on the middle of the table. Well, actually pretty much everything except for initial access and exfiltration and impact, you will see a lot of coverage. You know, execution, persistence, privilege escalation, you have ways to detect or find that activity at a really wide amount of tactics in the entire table. And because it's SQL, you need to write new queries. It's really easy. No one in your team needs to learn a proprietary language just for this. On the Uptycs side, what that looks like is we have a default configuration for our OS Query agents. So if you see here, these are the 141 queries that we run by default on the Mac. And as you can see, every single one of them has a different interval. For example, we check every 60 minutes, the third one from the top, the Active Directory configuration of a Mac. That's to know if it's bound to Active Directory, for example. We only check that every 60 minutes because if it changes, you don't necessarily need to know about that in real time. However, if you go a little bit close to the middle, you see select star from ARP cache. If something weird is happening to the ARP cache of a system, indicating someone might be trying to sniff network traffic, we want to know a little faster. So we're going to query that every 10 minutes. Now, you might be wondering, what if something happens in between these different executions? For example, there's a processes table. Well, if you query that, wait 10 minutes and query it again, would you even know if something was executed in between the two? And the answer is you wouldn't know with these tables, but OS Query also supports events. And these events use operating system features to stream different events related to hardware, processes, and network connections in real time, so you don't miss anything. Now, with Uptycs, because we have a backend that also uses SQL, We retrieve this data from all the endpoints and put it in our backend where you can query it in real time, or you can also go back in time and run the same query as and to see what the results would have been yesterday. And that's the reason why, if I go back, you see all these different queries are pretty broad, right? We don't filter much. We just grab all the data that we need. But to our end users, when they're using our real-time queries, they can actually write SQL, and it goes to our big data backend. So it looks like an SQL database, but it's not, because it wouldn't scale. And you can get all the results from all of your machines. So for example, in this case, you want to know what processes are listening and have the name SSHD, because you're trying to find all the SSHD servers on your machine. This is not going back to the endpoints. It's using the data that we got, unless you select real time, in which it will reach the endpoints to get the most recent data. So if we get to the actual attack framework part, I was looking at two detailed reports. We've been, well, I was going to say we've been lucky in the last few years that we got a few really detailed reports about different breaches. But that's not a great use of word, because as someone who's been in some of these major incidents, you don't feel lucky when it's happening to you. But as observers, this is really useful data. So I was looking at two different breaches, the SingHealth breach in Singapore and the Equifax breach. And I was looking at the detailed reports to see what I could use for this. And it turned out that the SingHealth report had a lot of detail about lateral movement, application servers, Citrix. It's a very entertaining report as well. If you haven't read it, I actually highly recommend it. Whereas the Equifax report was more about vulnerabilities and the management structure of IT and security. So I didn't end up using it much, because it's pretty hard to map a management structure to MITRE ATT&CK, which is a very technical framework. So I used the SingHealth breach. So for those that aren't familiar with the SingHealth breach, to summarize it quickly, this is a graph from the report. And as you can see, there's different interactions that happen here, and they're numbered. So at the bottom left, you have the initial entry, number 1, in August 2017. Now, if you look at the right, just right of that, 5B and then 5A, as you can see, the data was transferred or exfiltrated in June 2018 and July 2018. That's almost a year. So one saying that I hear sometimes that I don't really like hearing is attackers only need to be right once and defenders need to be right all the time. Well, if you look at this, these are all steps in the process of an attack where someone could have detected it and at least made it harder for that to happen. So if we're using a tool like OS Query and we're using MITRE ATT&CK to be sure that our coverage is great at every single layer, then these are many chances we have of kicking these attackers out before it's too late. So we're going to look at some of these, starting with the initial entry, to see what we could have done with OS Query for this. So as you could have seen on the previous chart, 2 workstations were impacted, but one of them was decommissioned at the time they started doing incident response, because it took a while. And the second one made command and control callback in August 2017. They know PowerShell and possibly user execution was used. And these numbers you see in blue, like T1086, these are the MITRE ATT&CK techniques that correspond to these. So they think PowerShell and user execution was used. Remnants of a public rat was found, though we don't know exactly what public rat, but we know it did password dumping, which that sounds like a repackaged version of Mimikatz or something like that. And there might also have been some spear phishing with a link or an attachment, but other indications point to that being the ruler exploit, which I'll explain in a little bit. But if it was spear phishing, that also maps to different MITRE techniques. So if we look at the OS Query schema, and if you just Google for OS Query schema, there's a great page on the open source OS Query site where they show you all the different tables, what operating system they work on. You'll see right away that we've got socket events and process open sockets. These events tables let us know every network connection that's being established by a machine and map that to a process. We also have a table that lets us read PowerShell logs as if it was an SQL database. And we're able to monitor what processes are running and what their parents are. And if it was the ruler endpoint, the ruler exploit, We can also check if Office is hardened properly with OS Query because we're able to read the entire registry with OS Query as if it was a structured database. Now, the ruler exploit, the way it works is that was a vulnerability in Outlook where if someone took over your Outlook web access account, essentially stealing your Active Directory credentials, they could create a rule in your web Outlook that would eventually execute code on a workstation running the full Outlook client. So by stealing your password, I could get code executed on your workstation the next time you checked your email. That's been fixed. And I think it's likely that this was used in the case of the Singtel breach because I don't really like the spear phishing theory unless webmail was used. Because if you've done incident response before, when it starts with phishing, over time you eventually find the real source of it, and you can prove that. In this case, they haven't, so it's not 100% sure. Now, you'll see a lot of SQL queries in here. Remember, you'll be able to download the slides, so you don't need to start noting down everything right now. You'll get the text if you want to use it. So first of all, with OS Query, you can select star from process open sockets. You'll get a lot of data about everything that's being established in terms of connections per process. If you already have threat intel data in your SIEM or your logging platform, that's a great thing to correlate with. If you can correlate process open sockets with your threat data, as soon as something is detected, you'll know what process generated it, not just what machine generated it, because we're on the endpoint. So we see network traffic, but we can augment that and see what process was running it. Now, in the case of a targeted attack, threat data might not help you if this might be brand new infrastructure, and so you won't detect it easily with threat data. But I always like to take specific attention to ports like 445 and 3389, especially when local IP addresses are used. That's great to detect lateral movement, but also to see where you thought your firewalls would block lateral movement and aren't. So we'll look at that in a little bit more details. But first, let's talk about the PowerShell part. So if you want to monitor PowerShell with OS Query, you need to be sure the script block logging is enabled. That's what makes PowerShell log the scripts. And you'll need to select the PowerShell events table. Now, if you're using Optics or any centralized OS Query TLS endpoint, you'll get the results back over TLS. So again, this is great because if a laptop is out there and PowerShell is executed on it, you'll get the results. There's a few things you can do with that, right? Either you send those results to a platform like Optics or you send them to a SIEM or a tool like Sumo Logic, for example. And there might be specific names or tools that you want to look for in these logs. So Gentil Kiwi, who's the maker of the tool Mimikatz that dumps passwords, for example, his name shows up when someone runs Mimikatz. Invoke shellcode is a command that you'll see pretty often with malicious PowerShell, such as people using PowerExploit. But the thing is, these are very static detections. You want to be looking for things like methods that are used, right? Do PowerShell scripts look like they're elevating privileges? Are they trying to use a get delegate for function pointer? These are all, they're not malicious, they're just suspicious in some cases. So when you're doing threat hunting, don't just look for specific tools, look for methods. And if you're using a tool like Optics, you can easily create alerts based on that. So the PowerShell events table also includes some other information like cosine similarity, which is a comparison of that script compared to other scripts that have been executed on this machine. So if you keep track of cosine similarity and all of a sudden you have a huge script, huge PowerShell script that ran that's highly different from all the other ones, that might be worth investigating. But a really simple one I like is script block count. I like it when I can spot that a script is much bigger than what I'm usually seeing. So you want to monitor that trend. So for example, with PowerShell, that table, you can see the date and time the script was executed, the name of the script, where it was stored, and how big it was. So by running this query regularly, you'll know how big your PowerShell scripts were, and that can let you find out where it's worth spending more time. Now, I talked about parent processes. With the processes table and the process events table in OS Query, you always have the PID of the parent. And so we have a quick script on the Optics blog on that shortened URL right there that lets you kind of create a tree view of that. Well, I'll show you what it would look like manually. So for example, if you selected everything from the processes table, you'll need to use subqueries if you really want to take this the whole way. But if you were to do it just manually, and I was selecting the PID, the name, the path, and the parent from processes, where the name of the process is services.exe. Well, if I ran that manually, and OS Query has an interactive command line that you can use mostly for testing purposes, testing that your queries work. So that's the screenshot you see here. If services.exe has a parent that is 476, I can't really know if that's suspicious or not because I don't know what 476 is. So I need to run a query to see what 476 is. And in this case, 476 is when init, and it's totally expected for these two processes to have that parent-child relationship. But if you saw cmd.exe or PowerShell.exe being a child of Word or Internet Explorer or Edge or Chrome, that would be quite unexpected and suspicious. So what you can do is write these queries that will get triggered, that will return results when something suspicious happens. So in this case, you want to know if winInit.exe is running and the parent is not services.exe. You want to return results. As I was saying earlier, if you're using Uptycs, we're returning more data than that because we're processing all of that in the back end. But if you're in an environment where you've got your own OS Query pipeline and you want to limit the amount of data you're collecting, instead of collecting all processes all the time, you can go and run queries like that pretty often. And because the results are going to be empty, if there's no suspicious result, you're not going to make your drives explode everywhere. And a quick shout out to Filippo Mattini, who's put a lot of these examples of parent-child relationships, especially for Windows, on his GitHub. Now, if you wanted to look back in time, because you're investigating something and you want to know what was happening on that machine a few days ago, it's pretty hard to do if you're just using vanilla OS Query and sending the results to a logging system. That's because OS Query has differential queries to reduce the amount of bandwidth and storage that is used. And then these results being empty for the differential when nothing has changed, it's really hard to put all that data back together and go back in time. So what we do with Uptycs is we add a lot of metadata to every result, such as the time the results came in. And so by doing that, we're able to say, this process was running at that time, and it stopped running at that time. And because we've got all that data centralized, we expose that in an easy-to-use interface where you would simply run the same query. But on the top left, as you can see here, I'm selecting the time machine. And when I select time machine, I get this, this time selection interface where I can pick a date and a time from and a to. So I can really go back in time and see what the results would have been if I ran that query on OS Query at that time. And that's again because we collect a lot more data. And that's awesome when you're investigating something, I especially like it when doing investigations on machines that don't even exist anymore. If you have very elastic cloud environments, for example, you might detect something, start an investigation, and realize that a container or a VM was exhibiting some strange behavior yesterday, and you don't have the data anymore because the machine is gone. Well, the data is in Uptycs or wherever you're sending your OS Query data. Now, if you're using Uptycs, it's going to be really easy to get to. Now, when it comes to Microsoft Office hardening, if some of you ever had to do that, perform the Office hardening, it's very flexible, but it's a little bit annoying sometimes because it's per user as well as per app, right? So I want to block macro execution for user Guillaume on this workstation, but I want to block it when he's using Word. I want to block it when he's using Excel, blah, blah, blah. And so wildcards become really useful here if you want to check multiple things at once. So for example, there's a setting in Office called block content execution from internet. And what it does is it prevents running a macro on Office if the file comes from the internet zone. So it won't mess with accounting's share where they have all their Excel sheets. But if someone saves something from Outlook or the browser, the macros just won't run. It won't even ask them if they want to run it. It'll just block. So that's a great setting. But that setting can be configured for multiple different applications. So what we would do is, in this case, select from the registry where the key is like, and then we have the path to what we want to check in the registry. So as you can see, this is not necessarily for threat hunting, it's more for security configuration management. But I like using MITRE for this because using MITRE ATT&CK for threat hunting and detection is great. But whenever you find these techniques like T1192 and 93, where you can actually make the exploitation harder by having better configuration, why not? So in this case, you see 2% signs that are wildcards. So in this case, OSQuery will go and look at every single user. That's the first wildcard. And then when it gets to Office /16 /, that's where you would have Word, Excel, PowerPoint, and all of that. So you can query this data very easily for all those different applications. And it's not that easy to see what user has those results, right? If I go back, you see the results here. The key is HKey users /, and then you have the identifier of a user. That's not very human readable, right? Well, I know some Windows people definitely know the identifiers of groups by heart, but you'll never know the users. So how would we make that readable? Well, that registry path actually contains the SID of the user. So we could run a subquery and split the data, because again, this is SQL, so that's a great thing. You don't need to learn any complicated query language. You just use SQL. So if you have anyone in your team that's already good at SQL, you could even get help from anyone from your business intelligence team or DBAs. They'll really be able to help you with the more complex queries without having to learn OSQuery specifically. So in this case, what I'm doing is I'm joining the users table to the registry table. So essentially what I'm doing here is saying, I want the data for the user, but replace the user's SID in the registry with the user's username, which in this case is G, which is my username on that test VM. And I know the data is set to 1, so content execution is actually blocked and Guillaume is configured properly on that machine. So these are the types of queries that you need to develop to do compliance and security configuration management with OSQuery, a lot of which comes packaged in Optics as reports and built-in queries. Now, if it was the ruler technique, you would do the same query, but instead of checking for macros, you would check the enable unsafe client mail rules, and you wouldn't want that to be set to 1. So same query, you just change the name of the keys. And honestly, I feel like you should probably check for enable unsafe anything and check if it's set to 1, because it sounds like anything that's called enable unsafe should probably be off, unless you have a really good reason for it being enabled. Then we get to lateral movement, which is where it gets fun. That was done over a period of 6 months, and malware was spread using shares. Weak local admin credentials were used. There was lateral movement and connections through Citrix and remote desktop, attempts to access a database. So as you can see, there's a lot of mapping to the MITRE ATT&CK framework in here that we can use OSQuery to detect or find if we're doing threat hunting. Now, what is lateral movement? To me, lateral movement, usually when we say lateral movement, we often mean Windows over port 445, right? Like it's using built-in protocols like SMB, but it could totally be done with other protocols, right? Like remote desktop, or on the Linux side, it could be done with SSH. Now, some good ways of preventing that from happening. On the Windows side, you want to use LAPS, which is Microsoft Local Administrator Password Solution, which is a tool that will randomize your local admin passwords. But you also want to identify accounts that are logging in wrong. And what I mean by that is, if you're a human, you should be logging in interactively. And if you're a service account, you should be logging in as a service or as a batch, and never the other way around. Now, we also want to look at that network traffic, but OSQuery also has the capability of letting you read all the different logs on your system. So maybe you're not centralizing all the logs from all your machines to a SIEM. Very few people are doing that with laptops, for example, because it would be very expensive, also very bandwidth expensive. But with OSQuery, it could be SQL Server logs, it could be Windows event logs, syslog on Linux, the logs on Mac. If you have a list of events you want to centralize, you simply have to query for those, and they'll be sent over TLS. So you don't need to set up an entire other agent for sending your logs out. But when I'm concerned about lateral movement, I definitely want to start with the network side of things. Now, we know that sockets are being established on port, let's say 445 in this case. Now, you might want to block that between your workstations using a host-based firewall, right? Why would laptop 1 be able to connect to a share on laptop 2? Management system, I could understand. But two laptops in the same department usually don't need to share port 445. Now, if you think you're blocking that and you have a big environment, a lot of business units using different host-based firewalls, sometimes it's a little hard to know what the real story is. So what I like to do is select process open sockets where the local port is 445. So that's going to be the listening port for SMB on Windows. And the remote address is not like, and then I essentially create a whitelist of my management systems and local hosts. So I'm thinking, okay, if 10.0.99 is my management subnet, and if I ignore localhost and IPv6 localhost, if I see any connection here, it means that someone is connecting laterally. It's probably not malicious, right? Like Windows is pretty noisy when someone goes to my network places and all that, but it lets me catch badly configured firewalls so I can fix that. And if I have reason to believe something suspicious happened, then it lets me filter out the stuff that I want pretty easily. And that query obviously would be longer if you had more subnets that you want to avoid. Now, we also talked about clear text passwords and weak passwords that was used, like the good old password with p@ssw0rd, which is great because it actually fulfills most requirements of password policies. Now, this is a little bit harder to detect with OS Query, though you can detect the use of these local administrator passwords. But again, what I would actually recommend instead of that is deploy LAPS and make sure it's configured properly, because again, we can read the registry. So same story, you find out where it's used in the registry, where it configures its stuff. In this case, you would look for this key to exist. And if your configuration said the local admin password needs to be reset at least once every 31 days, you could even go a little further and say, okay, I'm going to check that the password length is set, is not set to smaller than 31, or is set to smaller than 31 because we don't want it to be set to 60, for example. So these are all queries that as you find something during threat hunting, you deploy a new tool, you just add these new queries to your configuration so you get that data back constantly. And this is something that I would probably query for once every few hours, right? Like it's not something that changes all the time, but it's also not a huge amount of data. Then I talked about accounts logging in the right way. And by that I meant, if you're a service account, why should you be logging in interactively and vice versa? So something that happened at SingHealth that matches T1078 and T1081 is an account was used, a systems administrator account was used to connect to a Citrix server. And they thought that Citrix server would not let the local admin connect over Citrix, but it wasn't true because they were actually able to do that. Now, a good way of tracking that for threat hunting and just automated detection is to use the logon sessions table. And you can track powerful sessions with that. So here in the screenshot, I'm just selecting the user's domain, the server, the DNS server, and their UPN from that. So I see the accounts that are logged in. Now, there's another field that's very interesting here, which is logon type. So that lets you know if that login was interactive or not. And because we have that data, we can then easily build queries that will highlight the most suspicious stuff. So there's more than 100 people connected right now. I'm sure you have different naming conventions for service accounts. But one that I see pretty often is companies have a convention where service accounts have SVC underscore at the beginning of their name, or SVC dash, or S, or whatever. So now what you can do is select from that table where the UPN, which is the long username in Windows, is like SVC underscore wildcard, and the logon type is interactive. So that query will tell you, is anyone logging in with SVC underscore in an interactive session? And when you start running that at scale on all of your Windows systems, you will see that you'll catch a lot of things that are not necessarily malicious, like a sysadmin configured a backup job and the backup job ended up using their own account. Well, obviously you need to get rid of that, should be using a service account. And once you've done the cleanup, as soon as someone steals a service account and uses it to log in with RDP or in a console or something like that, you'll see it right away. So this is a great one. I love that. And then you can do the other way around, right? Like if the UPN is not like SVC and you're logging in not interactive, right? Because you want to find humans behaving as services and services behaving as humans, essentially. Now, there's things we can do in advance to prevent these things from happening in terms of good configuration. So I already talked about how we can check different configurations with OS Query. Now, on the optics side, we use that data to empower users by letting them know when their system is not configured properly. So this is mostly useful for companies where people have local admin privileges. So if you have a big engineering team where people have to be local admin, but you want to enforce a good level of security. So using the data from OS Query, we can write different queries to check that some settings are configured as expected. For example, as you can see here, is automatic update enabled, is file vault enabled, is your firewall enabled, the firewall being key to preventing lateral movement. And what we do with those is we integrate to Slack, and for each of these checks, we have a description of what is wrong and how to fix it. So in this case, what you see here is I received a message from our bot, Automate, telling me that my test Mac did not have file vault enabled, and it's telling me why I need to enable it and how we do that. So in the case of lateral movement, if someone turned off their firewall, they would get a message telling them to oh, maybe you turned off your firewall for troubleshooting and you forgot to turn it back on, but please turn it back on. So that's the kind of stuff we're able to do with the data from OS Query because it's so it's such a wide breadth. Then in terms of alerting, we get all that data back and we can create alerts in real time. So depending on where you're sending your OS Query data, that might be easier or harder. But with optics, it's definitely easy and very, very flexible. So we get the data back in real time, and you can write alerts using SQL for things that don't require extremely fast response time, or in JavaScript for a response time of about 2 seconds from something happening on a machine to the alert being raised. Then you can limit the noise by really precisely creating exceptions based on any field that OS Query has. So whenever you're doing threat hunting, if you find something that you think should be an alert, you're able to do it and exclude everything that would generate noise. And of course, we include a lot of these built in. You don't need to create all of these. And we're adding more and more that relate to MITRE ATT&CK. So our customers, from the moment they set up OS Query, are able to get some good information there. And it's just the use of creating these very, very flexible alerts. The fact that OS Query is open and the data schema is also open makes it extremely easy to use, unlike some commercial tools where the data format is a little bit more restrictive. So that was just the lateral movement part, the office configuration, and essentially the first 2 or 3 steps in that whole attack from SingHealth. And as you've seen, mapping attack to your OS Query configuration, so by that I mean the scheduled queries you have, is extremely useful because it's built on the real world. And with only a few queries, you can improve your detection. But because it's so easy to write these queries when you're doing threat hunting, because you can get data back in real time, go back in time if you're using optics, it's extremely powerful. And we include a lot of these built-in queries, alerts, reports, compliance reports, so you don't start from scratch if you're starting with optics. And I also want to talk about this this blog post here. Matt Not Max made a great article where he maps more of the SingHealth attack to MITRE, if you're interested in that. And some of you might be wondering, what about, okay, so SingHealth was mostly Windows. Obviously, OS Query is cross-platform, but what do we do with cloud? Well, now there's an attack matrix for cloud, and it has way fewer things for now than the attack matrix for Windows, for example. But it really lets you focus on the infrastructure, cloud infrastructure part of it, right? So the cloud APIs, the configuration of storage and container images and all of that. Now, you cannot query that with OS Query because OS Query is an endpoint tool, right? There's no OS Query for AWS essentially, because where would it run, right? I guess it could be a bunch of serverless functions or something like that. So what we've done is we've created our own integration between Uptycs and AWS, where we take the VPC flow logs, CloudTrail, and put all that data back into Uptycs. So you can then query that data using SQL just as if it was coming from OS Query. And that's super powerful when you combine both, because let's say you're doing some threat hunting using your AWS data, and you find out that one machine connected to an IP that you think is suspicious. Well, with VPC flow logs, you'll know what machine generated that traffic. But if you're also running OS Query on that same machine, you'll know exactly what process ran that and what user ran that. So it really lets you cover the whole stack, from the cloud infrastructure to the VM, the containers as well, because I don't think I've mentioned yet that if you're running OS Query on a host, you get a lot of the same data from containers without installing OS Query in the different containers. The same is true if you're running OS Query in a Kubernetes daemon set. So you can cover your entire cloud infrastructure, data center, hybrid cloud, as well as your workstations with a single agent, which is really great, because then you only have one language to worry about, one place where to store everything. And if you're using Uptycs, it becomes really easy to integrate. We've got many different integrations for different products. If you're using Demisto or Phantom or any kind of orchestrator like that, so you can speed up your investigations. So why should you be using Uptycs if you're interested in running OS Query or just getting all of that data back? Well, the first thing is Uptycs makes deploying OS Query extremely quick. As soon as you log into Uptycs, you can download a pre-packaged OS Query package that you can just deploy, and it's signed and it's pre-configured, and it will return data over TLS to our SaaS. And it's very scalable. We've deployed a customer in January on our SaaS that has over 100,000 Linux servers in a matter of a few days. We've got bigger customers than that, and it just scales, and it lets you run those same queries you would run on all of these machines and get real-time data. You could run a query on 100,000 machines and get results in a few seconds. We've got hundreds of attributes. We add a lot of metadata to that, as I was talking about, so we can show that time machine view. And again, it's multi-platform, works great for containers and cloud workloads, but I don't want to minimize how great it is on workstations as well. And then our historical system state is technically probably the hardest thing we've had to implement. The ability to let you run a query and go back in time. To the end users, it's extremely easy to use, and it's something that's really hard to implement if you're just sending that data to a standard logging system. So I hope that also motivates you to look at the different breach reports that are out there to see what techniques you can glean from there. What could you do to either improve your threat hunting exercises or improve your protection configuration by reading that? Because the data is out there. It's, you know, someone suffered for it. Let's all take advantage of it so we can all learn from each other's mistakes, and just make it a little harder for all the attackers out there. Be nice if they had to always work really hard to get to what they're trying to get. And with that, I'll open it to Q&A. You can go and go to webinar, submit some questions. Dave, did you have any comment on all that?
Well, there's certainly a lot to say, actually. I mean, you know, just walking through those various attack examples and sort of seeing the, you know, ability to go query across different types of systems for really specific data. I think it's always helpful to do those kinds of postmortems, right? Where you go, okay, what would have worked? What could have been helpful here to, you know, look at things like processes, look at all of these various elements that at this point we have.
Not to say that if any single one of these things was done, the breach wouldn't have happened, right? But it would have forced a different path to the attacker. And then when you start layering them, it becomes a much more difficult job, right, for them.
Exactly. Yeah, totally agree. Yeah, it was great.
Right, so one question we do get pretty often is API support. So everything that we have in Uptycs is backed by an API. So all the screenshots that you saw, everything has an API in the back end that you can use. It's an exposed, documented API. So that's great, because then instead of just using the data that's coming back from OS Query on your own, you can trigger automations. You can say, when we see this data from Optics or this alert gets triggered in Optics, well, send this to Demisto, send this to this different other tool. We integrate with a bunch of different systems like that, but we also have a lot of customers that have their own use of our APIs. For example, we have a large customer that doesn't use any security tool that cannot be configured via API. So every single alert that they have in Optics, except for our standard ones, they actually configure via API. So they have a nice GitHub repo with all the different detections they have, with all the different metadata they want from them, and they deploy them to Optics using our APIs. That's pretty great when you need to save time. And the other pretty common question we have is, what's included in Optics? Do we need to do I need to know all these different queries, right? Because I was showing a lot of stuff that you can do with the open source version of OS Query. The answer is, if you're using Optics, it comes with some pre-built queries, a lot of pre-built alerts, but we also correlate all the data we get from the events with some threat data that we have. So from day one, you get some useful results. And we also let you save and share queries. So if someone in your team wrote a great query and wants to share it, we have a really easy system for sharing those. So no, you don't need to know all the complexities of SQL to get started. But I would say anyone who's got a team that's advanced enough to do threat hunting right now, people catch on to SQL really quickly. And because it's standard, it's not like one more thing to learn, one more query language. So I'll give it two more minutes for questions.
Guillaume, are you seeing the questions in the questions window?
No, I am not. It is completely blank. And I was just asking you if that's a bug or there's no question.
Okay. What are the advantages? Sorry, let's do this one. The management console in the previous slide was Optics or something different, such as Collide? This came in quite a while ago.
It was this was Optics. This is all Optics. And I would say the main difference, Collide is one of our main competitors. They're attacking a different subset of the market. And I would say the biggest difference between Optics and Collide is really that backend database and the ability to go back in time. That's a huge differentiation we have. So we both use OS Query, but in pretty different ways.
All right, thanks. Is the underlying query language of the built-in queries visible, obfuscated?
So it's all SQL. Now, the context of this question makes me think that it's coming from a sense of, will the attacker know what the queries being executed are? So in that sense, yes, if someone is like local admin on the machine and they can keep track of everything that goes through the network and memory, they could see the queries being run. Now, one thing that we do recommend to our customers is, if you suspect that there's an intrusion happening, do not use the real-time queries. Wait for the data to come back to you, because if you schedule the data to go out of your machines and go to Optics every 5 minutes, the attacker won't be able to see that you're doing anything special as long as you're using the backend data. If you start using real-time queries, then you could tip someone off. So that's why we gather so much of the data in the backend, so you don't have to go real-time if you can avoid it. And it's got some other benefits, like it also works if a laptop is now offline, you'll get the latest results.
All right, well, that's all the time we have for today. Thank you so much, Guillaume and Dave, for your great presentation, and to Optics for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.